Okay, we're good. All right. Everybody at home, duck. Don't be on camera right now. Get your face out of there. I'm not presenting on this one.
How about we just do no math then?
No, I couldn't do that to you.
That sounds like a great
But I am presenting. I'm just presenting on the wrong one. Guys, I'm sorry. I'm so scheduled. I am presenting.
Yeah, you watched it. Oh, you have to change it.
Oh, I gotta put it up on here. Yeah.
There we go.
Oh, good. So now we've recorded that confusion.
Wait,
Great.
Miss Hart, you can't just like switch the computers. Like, say you mess up the first time, you can't just bring one down. And bring
Well,
the other
it's
one
because this one is plugged into there, so I have to be presenting from there.
up.
And then I need my grid up here so I can see the students at home.
Okay.
It's super easy. Though.
Super easy. I've made this really easy on myself. Like really. And I even made notes that clearly I don't choose to read to make sure I'm doing things correctly. Yes, it's good times.
For Christmas, we're all gonna chip in. We're gonna get you a big sign to put in your
Present from this one, turn the camera off. All right, I think we're good. All right.
Exactly.
Ready? Now we're good, right? Everybody's back?
Yep.
Can they hear me? Can you guys, I can't, they're black screen. I don't have any. You guys can come back on. We're good. All right, here we go. Let's do some slow. All right, so guys, really quick, last week we did the entire week on section 2.1, which was just working with a function, recognizing a function. What they're gonna want you guys to do next is graph a function, which basically leads into graphing a straight line. And I know you guys know how to do that. I can't figure out why we would go to graphing a straight line before we do slope. So I skipped to section 2.3. We're gonna do slope first, then we're gonna go back to section 2.2 and graph a straight line. All right, here we go. So slope. Slope is just a rate of change. It's basically a speed at which a line is rising or falling. So a straight line can do four things. It can slant to the right, it can slant to the left, it can be horizontal, or it can be vertical. Depending on what kind of slope you have, predicts which way your line will slant. Spoiler alert, if your slope is positive, you always slant to the right and you are what we consider to be a rising line. If your slope is negative, then you slant to the left, if you will, and we call that a falling line. I'm not going to tell you what your slopes are, these, we'll see them. These are your special kinds of lines. If your slope ends up being something special, it could be a horizontal or a vertical line. All right, so a line is literally straight because the slope is constant. It's growing at the same speed the entire time over the entire life of its graph. If it had a different slope in between 2 points, then your line could be jagged. It could not be straight. So the reason why they stay straight is because the slope is the same the entire time over the entire life of its graph. All right, let me just give you the definition of slope, and then we'll find it. And again, I hope you remember slope from Algebra 1. This is just a review. All right, let me move it up. Okay. So the slope of a straight line measures the steepness and the direction. They want to know, is it rising? How fast is it rising? Is it falling? How fast is it falling? That's what slope calculates. It calculates the steepness and the direction of the line. It does that by finding the rate of change between any 2 points. This is your definition, guys. Slope is a fractional comparison or ratio, so it should be given as a fraction. Every year, I have a handful of students who want to tell me the slope, and they give it to me as an ordered pair. Slope is not an ordered pair. It is a fractional comparison. It compares how fast a line is rising or falling compared to how fast it is moving left or right. So those are the infamous R words. It's comparing the rise to the run. So it's your rise, how fast it's rising, compared to how fast it's running side to side, left to right. Do you guys remember your rise over run words? Everybody remember slope, rise over run? Okay. So, in order to find your rise compared to your run, slope, which is always given with the variable m, we always use m to denote slope, which is a rate of change. It's literally finding your rise by finding the change in the y coordinate. So it's the change in your y coordinate compared to your run would be the change in the x coordinate. You run side to side, you run left to right. So guys, being that most of you have already learned slope in Algebra 1, it's usually a pretty easy section for all of you. The biggest mistake I see with slope is the students who want to put change in x over change in y. And I get it. X comes first in the ordered pair, y comes second in the ordered pair. Why can't it just be change in x over change in y? My only answer to you guys is that you have to take it back. You have to take it up with the people who invented slope. Way back in the day, when slope was invented, they literally defined slope to be the change in y over change in x. So it's purely the way it was defined. It has to be change in y over change in x. So please make sure you're doing that. Do not put x on top and y on bottom. That's usually the biggest mistake that I see. All right, well then in math, how do we mathematically find the change in something? We subtract. So it's going to be y2 minus y1 over x2 minus x1. So hopefully those formulas ring a bell. I just always feel better putting it up here. I don't mean to confuse anybody. It doesn't matter the way in which you subtract. So if you wanted to do y1 minus y2 over x1 minus x2, guys, live on the edge. You can do that too. We're all going to end up with the exact same slope at the end of the day. So both formulas work. All right, so here we go. So on your homework tonight, you're going to find slope two different ways. First, you're going to find it by looking at a graph. Then you're going to find it by using two ordered pairs. So let's do this first, all right? They want us to find the slope of each line on the graph. So guys, they've given us a line. This one slants to the right. It's a rising line, so you should already know that the slope ends up positive because we've already learned that in Algebra 1. If you go to the right, your slope is positive. So all you have to do is pick any 2 points. Any 2 points you want. I'm picking this point and this point. And you're going to count what was the rise compared to what was the run. So ask yourself, how many points would I have to, in order to get from this point to that one, how many would I have to go up to get to the next point? I'd have to go up how many spaces? 1, 2, 3. Would you guys say that up 3 is a positive movement or a negative movement? Positive. So you're going up 3. So now that means as far as your slope is concerned, your rise is a positive 3 over your run. Well, now, how many do you have to go to the right? Oh, I missed it. I went up a little too high. How many do you have to go to the right to get to the next point? 1, 2, 3, 4. Would you say right 4 is positive or negative? Positive. So now your run is positive 4, and there's your slope. Your rise compared to your run is 3 over 4. So guys, at the end of the day, this is not that steep of a line. The reason it's not steep, because the slope is telling us for every 3 units it goes up, it's going to the right 4. So it's almost moving up or down at the same speed that it's going right or left. It's going up 3 and right 4. That's pretty close. It's almost going up or down the same rate at which it's going side to side. So this would not be considered a very steep line. And then that's how it continues. Up 3, right 4. Up 3, right 4. Up 3, right 4 over the entire life of its graph. But then I always have students that say, wait a minute, Hardy, I wasn't going to do that. I was going to use this point and go to this point. That's fine. Watch. We're all going to get the same slope. If you wanted to go from this point to this point, rise over run. You rise up or down, you run side to side. So your rise this time would be, how many do you have to go down to get to the next point? 1, 2, 3. Down 3 would be negative. And then how many would you have to go to the left to get to the next dot? 1, 2, 3, 4. Left 4. So in that case, that person's slope would be a negative 3 over a negative 4. But guys, what's a negative over a negative reduced to?
Positive.
Positive anyway. So it doesn't matter. Any way you count this, we're all ending up with positive 3/4 as our slope. So like I said, pick any 2 points you want and count your rise and count your run. All right, guys, look at this one. Oh, and notice, it went to the right and our slope was positive, as it should be. All right, look at this line. Pick any 2 points. I'm picking this point and this point. I'm going to count my rise compared to my run. This time, to get from this point, I have to go down. How many?
4.
1, 2, 3, 4, which would be a negative movement. So that's negative 4. And then I'd have to go to the right, how many spaces? Just 1, which would be positive. So now my slope is a negative 4 over a positive 1. So guys, if you think about it, this should be a steep line. It's saying that for every 4 units you drop down, you're only going to the right 1. So you're dropping a lot faster than you are moving side to side. So this is a very steep line because of how much faster it's dropping compared to that run. All right, at the end of the day now, guys, what's negative 4 divided by 1? It's negative 4. So you could put that as your answer on delta math.
Wait, Miss Hardy, what if you did it like you went 4
Yep,
up?
okay, so now let's say you went from this dot to this dot. Then you would have gone up 4, which is positive, but you would have gone left 1, which is negative. So then you would have had positive 4 over negative 1, which it still reduces to a negative 4. So that's what I mean. It does not matter. You pick any 2 points you want, count it any way you want, we're all ending up with the same slope. And look at it. It's a negative slope, and look how it's slanted. To the left, because that's how negative sloping lines slant. All right, let's do the last 2. These are our special lines. These are our horizontal and our verticals. Watch what happens to their slopes. Everybody at home, we good? Thumbs up? Again, slope, I hope we're all okay. Just a major review. All right, look at this one. If we wanted to find the slope, right? Our slope. It's rise over run. So if I wanted to go from this dot to this dot, how many do I have to rise up or down to get to the next dot?
0.
0. You know, rise. So it's 0 over. How many do I have to go to the right to get to the next point? 1, 2, 3, 4, 5, 6. Not that it matters. 6. Guys, in the world of math, what's 0 divided by any number?
0.
0. So your slope is 0. It is not 0 over 6. You must reduce it to just 0. If you put 0 over 6, they're going to mark you wrong. That is not the slope. It's 0. So guys, all horizontal lines will have that no change in the y's, so they always end up with a slope of 0. All horizontal lines have a slope of 0. All right, last one, the vertical one. Rise over run. I'm going to go from this dot to this dot. How many did you have to rise up to get to the next one? The 4? 1, 2, 3, 4. Over, how many do you have to run side to side to get to the next dot? Nothing, so that's 0. That's a problem. Does anybody know what it's called in math when you try and divide something by 0? Starts with a U.
Undefined.
It's undefined. So now the slope is undefined. So it's not a number, it's literally a word. We're going to say this is undefined. All right, so the slope literally is a word, not a number. And that's all vertical lines. All vertical lines have a slope that is undefined. Now, the way I remember that the vertical are the undefined ones is by my 3 U's. My 3 U's help you remember this. When the line goes up and down, the 0 will be underneath the fraction, and therefore the slope is undefined. All right, so up and down, underneath, undefined. Your 3 U's. That's how I always remember that it's the vertical ones. If it's up and down, it's an undefined slope. Okay? All right, perfect. So guys, that's how you find the slope when you're literally looking at a line and all you have to do is count the rise and count the run. If they don't give you the line, they're going to at least tell you 2 points that are on the line. I don't want you guys to have to graph these just so you can count. All you're going to do now is you're just going to straight up use that slope formula. Find the change in your y coordinates compared to the change in your x coordinates. So now we're just going to use the slope formula. So the slope of the line that connects these 2 points, let's use the slope formula. y2 minus y1 over x2 minus x1. If I want to find the change, I need to subtract. Find the difference. See how much it changed. So guys, picture the first order pair. This is like your x1 and your y1, your x coordinate and y coordinate in the first order pair. And then think of this as your x2 and your y2, the second x and y coordinate in the second order pair. All right, the slope formula says to go from the second one to the first one. It doesn't matter, I'll just do that. All right, so we're going to take y2, which is 1, and we're going to subtract y1, which is negative 2. So you end up with a lot of double negatives, so please be careful with that. Over, now we go back and get x2, which is 1, and we subtract x1, which is -3. We just found the change in our y coordinates compared to the change in our x coordinates. Everything turns to addition, and you end up with 3/4. Guys, I just want to remind you, make sure your fractions reduce. On Delta Math, there's lots of fractions that need to be reduced. Always reduce your fractions. So guys, think about it. This is saying that for every 3 units it goes up, it's going to go to the right 4. That's not steep. It's basically going up at the same rate that it's going right. All right? Anybody know which one this would slant? So guys, when I say describe the slant, remember, a straight line can do 4 things. It can go right, it can go left, it can be horizontal, or it can be vertical. Which one would this line do?
Right.
Right. So just draw me a little picture that it would look something like that. It's going to slant to the right. It's a rising line. All right, let's find the slope of the line that connects these 2 points. Change in y over change in x. The biggest mistake I see here are the students who put x on top. It's not x on top, it's y's on top. Now the slope will be change in y over change in x. So I'm going to get y2, which is 5, and I'm going to subtract y1, which is -3. Don't let your eyes play tricks on you. Make sure you're getting a y coordinate when you need a y coordinate. Make sure you're getting an x coordinate when you need an x coordinate. All right, now we're going to go back and get x2, which is -3, and subtract x1, which is 1. All right, this turns to a plus, and we end up with -8. No, we don't. We end up with 8. 8 over -4. So guys, think about it. This is a really steep line. For every 8 that it rises up, it goes to the left 4. So it's rising at double the speed at which it's moving right or left. That's steep. But at the end of the day, guys, what does 8 over -4 reduce to?
-2.
-2. If you want to keep it over 1, you can, or you can just say it's -2. I don't know if Delta Math will accept that -2 over 1, but it is a reduced answer. All right, last 2. Let's find the slope of the line that connects these 2 points. All right, so the slope will be change in y over change in x. So let's get our y2, -4, and subtract y1, which is 7. Over, go back, get x2, -5. Am I still on camera? Yep. Subtract -5, which is going to turn to a plus. So I end up with -11 over 0. Guys, what do we call that in math when we try and divide by 0? When the 0 is underneath, the slope is undefined. So the answer has to be the word undefined. Does anybody know what kind of line it is if it's undefined? Up and down vertical. All right. Last one over here. You guys do it there. I'll do it here. Let's meet at the end. Let's see what our final answer is. Change in y over change in x. What's 0 divided by any number, guys?
0.
0. The answer has to be 0. 0. And what kind of line has a 0 slope? Horizontal. Beautiful. All right, guys, if I have time, I want to show you this really, really quick. Just hopefully eliminate any questions on the homework. Delta Math. Guys, let me just show you this before the bell cuts me off. On your homework tonight, on Delta Math, you have 5 questions where you have to find the slope looking at a graph, and you have 10 questions finding the slope using the ordered pair. So it's pretty quick. I just want to go over this with you guys in case there's any questions. So if they give you a line, first they're going to ask you to, I don't know what it says in the screen now. What does the direction say on this, on Delta Math? Up here? Up a little more. Draw a line representing the rise and the line representing the run. Okay, so what you're going to do is pick 2 points. Guys, make sure you pick points that literally are like points.
You're gonna have room, you're on the move.
No, this is good. So I'm on the camera, right? So I can see this is a point. Like it's not like crossing where it doesn't hit the meet points. And this is a point. So the first thing you're going to do is you're going to have to click on this point and then drag your cursor up and click on this point. And then you what? You went up 1 And then you're gonna click on this point again and run over to the side, which was what, 1, 2, 3. So Ms. Greenhouse, can you do that? Click on this point
Was it -4?
right here. No, over.
Sure, right.
Click it on, and then drag it up and click on this point.
Right there?
Yeah, click. And then it gives you that perforated line. Now click here again on the same dot,
Okay.
and then drag it over and click on that one. You see how you have to double click on the points? That's what you're gonna have to do on your homework first. And then you'll say my slope was up 1, right 3. Then you'll go to the answer box and put 1/3. Okay, but you have to click on that first. Is everybody clear with that? Okay. Everybody at home, did you see that? The clicking you're gonna have to do? Okay. All right, guys, you have a homework on Delta Math. It's due tomorrow night. Have a great day. I'll see you tomorrow.
Have a good day.
Thank you, you too. Oh, I gotta stop recording. On this one.
Bye, guys. See you later.